This is Twit.
Bandwidth for Know-How is brought to you by CashFly.
This episode of Know-How is brought to you by iFixit. You can fix it, and iFixit makes it easy with free step-by-step repair guides, high-quality replacement parts, and all the tools you'll ever need. For $10 off your purchase of $50 or more, go to iFixit.com/twit and enter the code KNOWHOW at checkout. And by lynda.com, the online learning platform with over 3,000 on-demand video courses to help you strengthen your business, technology, and creative skills. For a free 10-day trial, visit lynda.com/knowhow. That's LYNDA.com/knowhow.
Today on Know-How, it's a Raspberry Pi Wonderland.
We're going to show you an update to the Raspberry Pi MAME machine.
3D printing designs.
And taking your Raspberry Pi on the road with some portable power. Welcome to Know-How. It's the Twitch show where we build, bend, break, and Kamehameha. I'm Father Robert Ballecer.
And I'm Bryan Burnett.
And for the next as many minutes as it takes, we're going to show you some of the projects that we've been geeking out so that you can take them home and geek out on your own.
That's right.
We've got a special episode. This is sort of a Raspberry Pi theme. We're heading more towards these themed episodes.
I was going to say every episode is pretty special.
Yes.
But this is extra special.
This is like the super secret special PSA episode of... Never mind.
This is the delicious slice of pie.
This is so much pie, we can almost not handle it. But before we get to the pie goodness, I thought we should talk about something, since the pie is very, inexpensive and very efficient and very reasonable.
And it's certainly not because we had 4 of them lying around that we weren't using at the moment. We had to do something with them.
But since we're going to be talking about something that's very logical, we thought we should talk about something at the beginning of the show that was a little illogical. Fun, so illogical.
Okay, and what would that be?
Specifically, I want to talk about something that happened at the LA Auto Show this week.
I really wanted to go to that.
I did, but
apparently we don't cover that.
We don't cover that, but I heard from Tim Stevens, because I was chatting back and forth with him. He said, LA Auto Show is okay, but it was kind of quiet. He said, if you have to make an effort to go to a show,
Detroit.
Go to Detroit.
Yeah, that makes sense, because then Ford released all their new models, the truck, the supercar, and all that stuff. So that looked pretty cool. And us and Tim, we're pretty tight.
We're pretty tight. We're pretty tight. And it's funny because we are a tech network, but more and more we find ourselves wanting to cover the auto side because it is increasingly connected.
Well, it doesn't hurt that we were already kind of gearheads, but the fact that cars are now getting smarter, than most phones, then there's more reason for us to want to cover them.
Exactly, which is why I thought one of the stories coming out of the LA Auto Show was very interesting in that it deals with a car that they've actually made dumber.
What?
Yeah, I know. Go figure. Specifically, I'm talking about the Lamborghini. This was okay, I'm always going to mess this up because I want to say Hurricane.
It's
like the Huracan. It's the name. It's like a Spanish name for bull or something.
You gotta
Huracan. Now, it was the replacement for the Lamborghini Gallardo.
Oh yeah,
which is a classic. It's a classic. It was supposed to be sort of the no frills supercar, although really most supercars are supposed to be no frills by definition, right? It's just the driving experience.
Yeah, and as frills, no AC, heating might be an option. Usually you get shook around a little bit. But
it's not a daily driver.
That's the price you pay for something that has, millimeter thin glass, just so they can save like kilograms.
Exactly. And actually, Alex, you've got a link here that you can scroll through. This is what it looks like. So I do like the styling on this. This was an all-wheel drive with a 7-speed LDF dual clutch transmission, naturally aspirated, which I love because it's not a turbo, so you don't get that, you don't get the whine, you get that sort of that throaty
just that
growl.
raw power. Yeah.
Right, the raw power. It was a mid-positioned engine, which gave it really nice balance. 610 horsepower V10 engine, had a curb weight of just 3,100 pounds. So lots of power, not a whole lot of weight. It was a combination of aluminum and carbon fiber. Did 0 to 62 in 3.2 seconds, 0 to 124 in 9.9 seconds.
Not bad.
The thing costs $237,000. So yeah, okay, not a daily driver. Probably,
no, not a daily driver. Yeah. But I'm also surprised it's not a hybrid.
Exactly. We're seeing a lot of these supercars now go the hybrid route because that's just better. I mean,
the McLaren P1 is pretty famous for that now.
You add that electric motor, you get that low-speed torque, and you just scream off the line.
It's the best of both worlds.
It is the best of both worlds, but the thing with this Lambo is they wanted to keep the sort of the natural feel of a supercar. They wanted it to be, it's supposed to be a little bit crazy, right?
Well, yeah, that's why you usually would buy a supercar if you could afford it.
Exactly, and they felt that, well, with all the electronics, it gets a little too safe. So they backed off on the hybrid system, and even the you could individually control the amount of power going to each wheel. That was dumbed down a tiny bit to give it more of a feel.
So this is kind of the Lambo for the purists, like us. So this is the next Lambo you're gonna get.
It was, yeah. This is my wish list. This was supposed to be the Lambo for the purists, but it wasn't. Actually, Richard Hammond from Top Gear, season 22, we both liked, loved that series.
Top Gear is definitely one of our favorites. We've drawn a little bit of inspiration, I'd say, from that.
I think so.
On that bombshell.
Yeah, I think so. On that bombshell. No, but he said he liked it, but the problem is it felt too disconnected. You know, it was supposed to be crazy, and you couldn't really do anything to make the car go out of control, which you kind of, I mean, you need. I mean,
yeah.
He felt, and this was the worst condemnation I ever heard. He goes, "This is a car for the new rich and the stockbroker." And like,
who just want to like have
show how cool
the
my
name
car is.
And
right. Who will never drive it above 40 miles an hour.
Who won't take it to the track. Yeah.
Exactly. So at the LA Auto Show, and this is a long way of getting to this, they actually released the second version of this car. And it on the surface, it seems a little weird. They bumped it down from 610 horsepower down to 580 horsepower, which is kind of strange. Again, they backed off on some of the electronics, but here's the big thing.
Yeah.
The first one was all-wheel drive.
Most Lambos are.
Most Lambos are. This is a rear-wheel drive only, just two wheels in the back.
So they took out the power and they made a rear-wheel drive.
And they cut back a little bit on like the electronic handling and suspension.
Right.
So this is supposed to be like a purist car. You really, if you put your foot down, you will spin out. Which, you know.
So has anybody reviewed this rear-wheel drive one?
Oh, they just announced it at the LA Auto Show. I want Tim Stevens to review it. I want to see what happens when he puts his foot down.
And I mean, they dropped the price from $237 to $200.
Yeah. So now it's affordable. I can get two of them now.
Yeah, instead of buying that extra, now I have enough money to buy that extra Prius, when I'm not driving the Lambo.
Right. But this is interesting. The reason why I like this story is it's a little bit crazy. We're always talking about more tech, better tech, making it more advanced. This is sort of saying, okay, wait. If we want this to be fun, we have to back off a little bit. Yeah, we could make this all-wheel drive. Yeah, we could make it so that the computer controls every little bit of minutia that goes on in the cabin to make sure that you never get in trouble.
Right.
But then what fun is it if we do that?
It's, taking all the risk out of it also makes it not as much fun.
Right. It's a driver's car, not a commuter's car.
Yes.
Of course, for $200,000, I don't know how many people will be commuting in this car.
I don't know either. I mean, for $200,000, if you really wanted the purest experience, you could always just do like the Ariel Atom, which doesn't have, any electronics, and it's basically just the open cart setup.
It's an engine with some pipes.
That's why I like motorcycles, but they're also very inherently dangerous.
We've got Slow-Mo and Dr. Morbius in the chat room. Slow-Mo saying, well, 200K seems high unless it flies. And Dr. Morbius is saying, well, you need 610 horsepower to navigate LA traffic.
Yes,
which is
absolutely.
Yeah. Okay. So, if you've got an extra $200,000 and you want to buy a car that will try to kill you, then you need to pick up a Lambo Huracan.
It is an interesting convergence that we've gotten to, where the computers have gotten so good that it's like it's not fun anymore. So we have to make it less smart. Like.
That is weird, isn't it? To say, well, we figured out the physics of this so much that we can make it so you can never push this car out of control.
It's like leaving the training wheels on, though. You take those training wheels off.
You gotta crash a little bit.
At least give the person the option to turn stuff off as you go along. And then when you get back into the LA traffic, you just turn everything off when you're in the LA traffic.
Because you're not moving. Why do you need it? Just leave the car at home. When we come back, we're going to be jumping into our Raspberry Pi Wonderland. We did a very popular project two years ago. I think it was 2 years ago, right?
It was a long time ago.
Long time ago.
That's why
One of the very
People are
first
wondering
episodes
why
we
I
did.
shaved is because I went back and watched that video. I was like, oh my God, I used to look really good without a beard.
So baby-faced.
Yeah,
so
right?
baby-faced. Well, we've got it here. This was the original Pi. This was the MAME project that put a Raspberry Pi inside of an old NES shell. And we will talk about this project and what went into it. Now, Bryan thought this is a good time to update because we now have this new Pi. We've got the Raspberry Pi 2B, which is way more powerful, and they've also improved the installation of the RetroPie system. So we're going to go ahead and take a look at this. But before we do that, let's go ahead and thank the first sponsor of this episode of Know How. Now, hey, Bryan, you know, sometimes I like to take stuff apart.
More often than not, yeah.
More often
Probably
than not.
when you shouldn't.
Most likely when I shouldn't, but when I do, you know what I like to use?
iFixit.
iFixit,
Me too.
absolutely. iFixit is the know-how choice for disassembling, repairing, and reassembling all your gadgets and gizmos. Now, if you want screwdrivers, they've got that. If you want suction cups, they've got that. If you want repair guides, they've got that, because iFixit isn't just a place to buy your tools, it's a place to get your knowledge about every single repair possible. Now, we've got something new. It's the Business Repair Kit. This is an all-in-one kit that allows you to, well, have everything you need to start up a repair business or get on the go and fix your devices is inside this bag. That name says it all, Business Repair Toolkit. If you want to pack everything into a nice custom shoulder bag with everything from a multimeter to your drivers to this anti-stack pad, well, that's what you get. It includes the ProTech Toolkit. That's the iFixit standard for repair toolkits. 70 tools to help you dish sweet repair justice on all your broken stuff. It's also got a magnetic project mat, which Bryan and I both like because it means you can take out your screws and leave them stuck to a mat with a nice little label next to them so you always know where they go. It's also got the ProTech Toolkit, which is a nice set of hex drivers and drivers for every kind of little repair job. It's also got an eye opener, which they invented. It allows you to apply consistent heat to adhesive-laden case components. A heavy-duty suction cup set so that you can pull screens off of iPads, iPhones, and the like, as well as lots of plastic opening tools. If you've ever tried to open a case with a screwdriver, you know that it's a really good way to destroy the case. Don't do that. Use one of their nylon spudgers or their metal spudgers so you can get the case open, repair it, and get it closed, and no one will ever know that you were in there. They also include cleaning tools like a dust blower, screen cleaner, microfiber cloth, and a brush so that you can get the dust out, which, it kind of makes our systems feel gummy. All of this is neatly organized into that messenger bag so you can move from one job to the next, knowing that you have everything ready to go. There's nothing more frustrating than showing up and realizing that one tool that you needed, you left at home. Don't do that. Go ahead and get yourself an iFixit Business Repair Kit. This is the all-in-one kit to kickstart your business or your life as a maker. Best of all, iFixit has guides and tutorials to help you put all those tools to use. This is only $249. That's $100 off what it would cost if you bought all of these tools separately, and iFixit will back it with every bit of knowledge for you to repair your Xbox or your iPhone, replace the battery on your Android tablet. Really, if you want to fix things, you should be iFixing it. Now, here's what we want you to do. We want you to fix it, and iFixit can help. When you visit iFixit.com/twit, you can now save $10 off any purchase of $50 or more by entering the code KNOWHOW at checkout. That's iFixit.com/twit, and use the code KNOWHOW to save $10. And we thank iFixit for their support of Know How.
Slow-mo in the chat room also pointed out teardowns, which they just tore down the Apple Pencil. What do you think the repairability score is on it?
0.
One being not repairable at all, and 10 being repairable.
1. It's got to be 1.
It's a 1.
You can't know. You open that.
They took a Dremel to it to get it open. So yeah.
It's okay. It's only $100. You should buy like a pack.
No big
Pack
deal.
of 6.
Yeah, I just like going on their website to check out the teardowns.
Yeah, it's interesting to see what tech lurks behind the surface of our favorite gadgets and gizmos.
Yes, I think even when they did the GoPro, the Session, the little tiny one, they did X-rays of it because it was so. It's not meant to be taken apart at all.
Why don't we have an X-ray machine here?
Do you think anyone would trust us with an X-ray?
I wouldn't trust us with an X-ray machine.
Hey, Alex, you want to know what your bones look like?
I already do.
Oh, right.
Oh, right.
Hey, you're fully healed now.
Push them buttons. All right, this is something that we didn't just build, but this has been in pretty much constant use since we put it together.
Yeah, for better or worse, we've definitely put a lot of man hours into this project. This was my baby when I first came onto the show. You and Ayaz helped me put it all together. But so 2 years ago, the original Pi, we made a MAME, we put it in an NES. We used the original power switch, which was pretty cool.
Yep.
So the LED worked and everything, and you could use this to send the signal to the Pi to shut it down.
That was big, because a lot of people, when they're done with their MAME, they just pull the power.
No,
they don't
you
want,
don't. No. You gotta like unmount the card.
You have to kill. You have to kill all the processes. Yeah. Otherwise, you leave a bunch of temp files. It's a really good way to kill the OS and have.
It's a good way to bork your SD card.
Yeah.
So that's still the case.
And this wasn't just a power switch. This is actually this is something that we purchased online, but we interfaced it with the existing power switch that came with the NES. So when you push the power, it doesn't disconnect power from the Pi. It actually sends a signal to this board, and this board sends a command to the Pi to do a safe shutdown.
Right, and it goes through this GPIO port right here.
Right.
So yeah, that was pretty nifty. That took a little while to get, and we had to put a resistor in line so that the LED came. I think we popped a couple LEDs trying to figure that out. But so yeah, that was a really fun project. If you go back in the know-how like YouTube page,
it's like 66, I think.
It's way back there now.
Back. We're over 100 episodes ago. Oh, the other pieces in here. So we've got is this the original Raspberry Pi?
That is the original Raspberry Pi.
Original Raspberry Pi, but we needed to break the headers out because, of course, the Raspberry Pi is not as big as this case.
Right.
So you've got a USB. This is a USB hub that you've taken out of its shell. That provided both connectivity and power to all the different devices in here that needed it.
Right. Well, one of the first changes you can see between the first Pi and the second Pi is that there was far less USBs.
Right.
There's only 2, so we had to get a little board here to break out some of the USB stuff.
And then those headers go to the USB headers here so that you can actually plug in the controllers at the front of the case rather than having to open up the case and connect the controllers.
Right.
Then you've also got, this is a standard Keystone jack that you cut down.
I think we could do this a lot better if we did another.
Now we could.
Yeah.
Now we could. Because we had a deadline. We're like, just put it in there, hot glue.
And then, yeah, we have the Ethernet hooked up in here, and Ayaz was convinced that if we didn't have a certain length of Ethernet, we would have crosstalk or something.
You need to have over, I think it's, you want 13 inches of Cat5 cable, otherwise you get a standing wave inside the Ethernet cable.
At this point, I would rather just put a Wi-Fi dongle or something in there and get rid of all that cabling.
Well, that's the thing. I mean, we look at this project, and I love the fact that we did this, because this was so much fun, and it was cool. The first time people see this in a NES case, they think, oh, it's a Super Nintendo, it's a Nintendo. But we kind of moved past that. Like, we don't need to make it look retro anymore. Yeah. We wanted to go with an updated design, and we also wanted to take advantage of the fact that they really improved the Raspberry Pi since the first version. And this is so much better.
Oh, yeah. The new Raspberry Pi kicks butt when it comes to playing old games like that. But not only that, but the community around building the MAME software, give them 2 years, and they've done a lot. It's a lot easier than it used to be.
Hold on, here. Okay, so I've got an original Raspberry Pi here. And so we can put them right next to each other.
Side by side.
Side by side. So
then you don't look terribly different, but you can tell like there's a lot more GPIO ports, there's more USBs, better processor, more RAM.
Now the new one does lose the standard RCA output. You can still do it through this port. You can get the analog.
Right.
But I mean, pretty much everything else is the same, aside from the fact that this is so much more powerful.
Yes,
it's
and
ridiculously more powerful.
The old one would take standard-sized SD cards. The new one takes micro SD.
Which I like, because in the old one, the SD card actually sticks out. It sticks out from the board. This one, you can actually get it all the way in, and it just has a little bit of overlay.
Yeah, actually, what I did for this old one, I can't really get to it because it's like trapped under there. There's a little micro SD adapter that you can get. So if you don't like the SD card sticking out, you can get an adapter for the old one.
Yeah, but we don't have to do that anymore because we've moved on to the new hotness. Now this right over here. This is the new hotness. Let's take our beautiful MAME machine and move.
I don't know, Padre. I'm seeing numbers, wires. Which one of these do I cut?
Bomb.
Which one do I cut?
Always cut the red one.
Oh, okay. Well, that's easy enough to
this is something we're going to be talking about. This was just a little 3D printed shell. I wanted a prototype box, something that we could play around with, something that was easy to access. So I made this really quickly. We're going to show you how we made this 3D shell. This was just Tinkercad.
Right.
which we've shown on.
This
on
is revision 1, right?
This is revision 1. But there's a couple of things that I like about this. First, because we've got enough USB headers, I wanted to have the USB ports close enough to the edge of the case so that we could actually use the internal ports rather than having to hook it up to another USB hub.
Right.
We don't have to do that anymore. Why? Why do it? The other thing about this was I now have access to the SD card. So if I wanted to swap out the image, it does take a pair of pliers.
I was going to say, you kind of have access. Where did you put those pliers?
The pliers, they're down here, yeah. We'll show it in a bit, but now I can actually swap out the SD cards by using a pair of pliers rather than having to disassemble the entire thing to get out the SD. But the big thing you'll notice here is this is portably powered. So this is running off of this battery. Yeah. And we're going to show you how we did this because it's not as easy as just plugging in a battery. We wanted it expandable.
Oh, okay. And then you've got this, and there's stuff hiding under here.
We'll show off all of that stuff.
Oh, we'll get to that.
We'll get to that. I mean, a lot of that is sort of unnecessary because we are running off a battery. But since this is going to be our sort of prototype box for playing with Raspberry Pi projects in the future, I wanted the flexibility of being able to hook up an AC adapter. You will notice here, this is normally where you would power the Pi. That's the USB port.
Right.
That is a pain in the butt to have a wire coming out from the battery out of the case and then plug it back into the case.
Right.
So I'm using the GPIO header to power the Pi, but we'll explain why that's not as easy as just plugging something in.
Yeah, this looks really clean though. I like this.
We wanted clean. We didn't want a lot of excess cables. And that's what we're going for.
Because you could totally just throw your controllers in your backpack, throw that in your backpack, and then head over to someone's house and you have your game machine. You don't even have to plug it in the wall.
Right. And remember, we left this open, but the design actually allows for us to put a top over this thing. So literally, it's this size. This battery will run this Pi for about 6 hours.
Nice.
And I can put a battery that's got about twice the capacity. So I could run this thing wirelessly for about 12 hours.
That's awesome.
Yeah, it is kind of cool. But we're not talking about the hardware yet. We need to talk about RetroPie.
That's right. RetroPie is where you will go to find all the software you need to first set up your Pi and then put your ROMs on. And 2 years later now, having done it, it is so much easier. Like, I was hesitant to even do a video on it because they have such a good website and following the instructions and everything. But it's kind of good to do a little walkthrough. But Alex, if you play the video, this is the website, the Pet Rock blog, and this is the community that has built up the software and everything. And we'll have links to this in the show notes. But if you go to their page, you'll download the SD card image for your Pi. They have a separate image for the original Pi and then the Pi 2. Considering I'm doing this new project with the Pi 2, I just downloaded the Pi 2 version, and they have this page here where they walk you through all the steps that you're going to need to go through, and it's so much simpler because I used to have to do commands in the terminal to kind of get some of these prompts to come up, and you don't have to do that anymore. They have these really nice diagrams for the controllers, but when you do go to download it, you're gonna want to torrent it. Don't direct download. I tried to do that.
It takes like 3 hours.
It failed. It failed like after an hour.
Ooh.
So I had to download it via torrent. Use a little SD card adapter to plug it into my computer. And another program, depending on what OS you're using, I'm on a Mac obviously, so I'm using the Apple Pi Baker, and it's got a little cute logo.
See, that's what I love about this, because you download the image and then it writes the image to the SD card versus the old way, which was you install your base OS and then you use sudo apt-get to download all the packages. This has all the packages in one spot.
Right. It's a complete package. You use this to first format your SD card, and then you take your downloaded image and you just copy it onto the card. And once you're done doing that, you plug it into your Pi and you just go through the controller settings. So I was going to try it with the original Pi just to see how it worked back to back. But I was working on this last night, so I kind of gave up after a little while. But this is the original Pi, and I sped it up. And this is the original interface. I just wanted to show what the original one looked like.
Which I really liked.
Yeah, it was nice, but I had to program all those names and descriptions and everything into it. Like, it'll scrape it a little bit, but it was not very good. So I was like, and it took, I think I timed it, it took about 25 seconds for a full boot up. I took all the wires off of the other Pi and I plugged in the Raspberry Pi 2 with the new SD card and OS and everything, and it boots up a lot faster, and the interface is a lot slicker. So when you first turn it on, it already will prompt you to input your controller settings. So you follow the prompt. Before, I had to do that in terminal, and it was really difficult. And you had to do it by numbers.
This is a lot nicer.
Yeah, so this is really slick. But before you put any ROMs or anything on it, you're gonna go into the RetroPie little dock station here and go down to the Raspberry Pi configuration and tool, Raspberry Pi config. And what you do here is you expand the file system, and that just allows you to take advantage of the whole SD card. And that's something that's carried over from the last one too, but this was way easier to do it, and there's a lot less full shutdowns that I had to do. You just press F4 to reboot the emulation station. And then I was really surprised how easy it is now to transfer ROMs. So you just take your a USB drive, and you put a folder on it called RetroPie, plug it in.
And it copies over.
Well, so I haven't put any ROMs or anything on it until now. And what it does is the Raspberry Pi makes a file system on it with all the emulator folders.
Oh, nice.
And then you take the ROMs that you have after you've plugged the USB into your PC or whatever, and you drag the ROMs into the according folder, and you plug it back into the Pi, and it copies them over, and then it just populates the emulators that you have ROMs for.
Oh, so nice.
Yeah,
so nice.
and then that was it. And then my ROMs were on the Raspberry Pi.
I have to say, because I remember how much of a pain it was every time the install borked out and you'd start fresh. That's so much easier.
No, this is...
The longest part was the downloading.
This was pretty amazing. Because the original one, I actually did FTP because I was transferring... it was easier for me to transfer the files that way. But just putting them on a USB, plugging the USB into the Pi and having it just pull them, it took 2 minutes because these are really tiny. ROMs are really tiny.
What about the performance? I mean, the Raspberry Pi 2 is a considerable amount more powerful than the original Raspberry Pi.
Yeah.
Did you notice any performance gains?
So the old Pi would not play the N64 games. It could not render. Yeah, it was not good. This one, the first game I tried was Super Mario 64. It was smooth. It ran really smooth. Right. So that was a clear performance gain. Those old games, if you're only going to play NES or Sega or something like that, you might not see much of a difference because those games are already so basic. But if you're going to try and do PlayStation, N64, anything with a little bit of 3D rendering, the Raspberry Pi is blows the other one out of the water. And with the new interface and everything, I didn't notice any stuttering. It's just really smooth going back and forth between things. So I haven't had a ton of time to just really audit it, but I'm really liking the Pi 2 and the software. They've done a really good job with that.
And we should say that you cannot just take the card from a Pi 2 and put it into a Pi 1.
I tried that.
It won't.
I tried that last night.
Yeah.
And no, I think the boot system is different. So yeah, I couldn't just I wanted to take the old card, put it in the new Pi, and just see how it ran. Couldn't really do that.
So let me ask you this. If someone has built our MAME machine from way back in the day, would you suggest it's time for an update? Because it's going to, they can use all the same parts, but it's going to cost them about $40 to get a new Pi and another $10, $15 to get an SD card for it, a micro SD card. Would you say, yeah, go ahead and update?
I would say update if you are at all interested in doing 3D games. So N64, PlayStation games, maybe Dreamcast games. But it might be worth just redoing this project because how much better the software is.
Yeah.
Because on the old one, I really wanted to do Game Boy games also. On Game Boy games on the big screen would be cool. But it was a real pain in the butt to get the emulator software to work.
My favorite part was when I was trying to get new ROMs to run.
Yeah.
I was always balancing it against the possibility that in doing what I needed to do to get it to run, I would bork the system and have to start from scratch. So I got to a point where I'm like, you know what? I've got enough games on it. I don't really want to mess with this anymore.
I think this whole project, like even the old Pi and the controllers and everything, I think these controllers I got off Amazon, these USB controllers were, I think, $10 a piece. The Pi itself, the new Raspberry Pi is like $40.
Plus $10 for the card, 10 to 15. So I mean, with the two controllers, you're looking like $70.
You're looking at it. The cost of this project is how much a brand new game costs now.
Yeah.
So if you're buying Fallout 4 or something like that, that's how much this project cost me. But I'd say if you wanted to try out the software, keep your old card. And then just get a new micro SD card, do the new software, see if you like it, if you want to try it on your old hardware. And if your old system, your old Pi kind of chugs on it, then yeah, maybe get a Raspberry Pi 2 and play with it then.
And the nice thing is, it's not like you're tossing out your old Ras Pi. I mean, you can still do plenty with the original Ras Pi, you just wouldn't do games with it. I mean, it could still be your general experimentation Ras Pi, it could still be your sensing Ras Pi, you can still hook up a display to this, which we'll be showing later on.
Just don't use it as a desktop computer.
Don't use it as a desktop.
I tried.
No,
it's not.
Don't do
it.
It
Can't.
Just don't.
It can't.
Just don't. Just no. Just no. Now, we will be coming back to this because we want to show you what we did to create sort of our little platform here, our prototyping platform. And I also do want to show you how we made the mobile power solution for this Raspberry Pi, because it's really not just as easy as plugging in an external battery pack. It really isn't. But before we do that, let's go ahead and thank the second sponsor of this episode of Know How. Hey, Brian, you know what I like? Knowledge.
Okay.
Where do we store our knowledge?
I thought you were going to say steam buns, and I love steam buns.
I do like steam buns, but I like knowledge more.
But when I'm not filling my tummy, I want to fill my head.
Yeah, your knowledge hole. When we fill our knowledge hole here at Know How, we have one place that we like to go.
Linda.
Lynda.com. Now, Lynda.com is the place, the repository of knowledge on the internet. A one-stop shop for the curious, for the problem solvers, for the people who just want to know. Now, if you want to increase your business skills, let's say you want to learn PowerPoint, you want to learn Excel, you could do that at Lynda. Let's say you want to learn how to program. Yeah, you could do that at Lynda. Let's say you want to learn how to take better pictures. Well, that's exactly what Lynda is for. If you are one of those curious people, you owe it to yourself to check out Lynda.com. Now, their latest courses include music production secrets, performance tuning your Canon digital SLR, and producing professional podcasts. There's also a weekly series on communications tips, which can help you hone your communication skills in order to deal with cranky hippo, difficult people,
What?
influence others, and confidently speak in public at a moment's notice. That's right, difficult people. With a Lynda.com membership, you can watch and learn from top experts who are passionate about teaching. You can stream thousands of high-quality video courses on demand and learn at your own on your own pace. You get to learn the way you want to learn. The courses are structured so you can jump in, jump out, save your place. In other words, they don't want you to have to follow along a lesson. They want the lessons to complement the way that you absorb knowledge. You can browse each course transcript to follow along or jump specifically to a question of reference that you might have. That one thing that you just can't figure out when you learned Adobe Premiere so long ago, just type in your question, find the spot in the transcript, and then find the corresponding spot in the video. It's really that easy. You can also download tutorials to your Android, your iOS device. You can watch on your Mac, your PC, your laptop, your desktop, and you can create and save playlists to share with your friends to bring them into your love of all things knowledge. So here's what we want you to do. We want you to get learned up with Lynda.com. Your Lynda.com membership gives you unlimited access to training on hundreds of topics, all for one low flat rate. Whether you're looking to become an expert, you're passionate about a hobby, or you just want to learn something new, Cranky Hippo and I want you to visit Lynda.com/knowhow. Lynda.com/knowhow. And sign up for your free 10-day trial. That's Lynda.com, Lynda.com/knowhow. And we thank Lynda.com for their support of Know How.
Go fill that knowledge hole.
Go fill it.
Wow. So what are we going to talk about now?
You know what I want to talk about? I want to talk a little bit about 3D printing.
3D printing.
We love ourselves.
The one thing that you have not let me do, because every time you say you're going to bring it to the studio, it's broken.
Heavy. Well, it did
And
break.
it's heavy.
I did actually break it this time.
How many is that now? 3?
It's 3.
Yeah, I thought so.
I got to start breaking these things. I have learned that some of these machines aren't really designed to be constant duty. You can't run them 24 hours a day, 7 days a week.
What are you building? I know you were trying to build a little corgi statue at one point that broke one of them.
It so broke.
Typical. Yeah. A 3D printer can't handle the power of a corgi.
Can't handle the power of a corgi. Well, okay, so the problem that I've been having with my 3D printers is, again, I run them constantly. They're all, I mean, even right now, I've got 2 of them that are still running.
So if there's any 3D printer people out there who want us to test their product, give it to Padre, because he will give it a run for its money.
I will. It's not whether or not I will test it. I will tell you how I broke it.
Yeah.
How about that? Let's do that. But no, so what we wanted to do, again, we talked about this a little bit in the last segment, was we wanted to build a new case. We didn't want to be bound by something we downloaded. We wanted to have something that we thought we could use in future projects. Yeah. And so we came up with this. Again, this is our little prototype Pi. You'll notice a few things about this case. First of all, I did want the square because I was thinking about stacking. I want the ability to sort of stack these modules on top of each other. So you can have like the processing module, the battery module, maybe the sensing module, and I want to make all of these containers stackable. So there's a little mechanism that you can like lock them into one another.
That would be cool. How far beyond this would your 3D printer bed extend?
That's the other problem. I can only go about 20 millimeters more on any side.
And that's when you start getting like the frayed edges and stuff?
I just run into the edge of the platform. I just won't print past that. So this is the format I chose because I wanted a couple of things. I wanted access to the SD card. I did not want it to be like the NES case that we did for this, where you have to remove the Pi in order to get to the SD card. This way I can switch out between Raspbian, between the RetroPie, and between my Raz OMC, the Media Center, with one prototype board.
Right.
The other thing I wanted, and we remember with the NES case, we had to break out these ports. Yeah. Because it was buried, if you look, it's buried in the middle of the case. So we needed all these little cables to sort of get it out to the edge of the case.
Because there was no way that we could make the USBs face out here without blocking,
Exactly. I didn't want to have to go through that because as you can see, you did an excellent job of tidying this up and making it neat, but that's a lot of cable, and it's a lot of cable we don't really need now that the Raspberry Pi has all the USB ports I want. So I wanted these ports to be right up to the walls of the case, the SD card, the power port, the HDMI, and the audio out port, so that I could play with it without having to break out.
Right.
Now this was the sacrifice I made. Unfortunately, I couldn't get the USB port and the Ethernet port to be dead flush against the wall unless I made this really skinny and then pushed it out. And I kind of like that square format because it really is space efficient.
Right. It'll probably make it easier to stack too.
It also makes it a lot easier to stack. One thing I am thinking about is I'm going to 3D print a solid header on this that will actually extend the Ethernet and the USB ports straight out. So I am working on that.
Okay.
Either that or I can bring in this wall, but again, I don't want to make it too skinny.
Yeah.
I didn't feel right about that. Let's actually look at what we did to make this happen. This is Tinkercad.
Tinkercad.
So you'll remember this. This is what we used when we made the Twit badge. Now, I didn't want to have to design everything from scratch. So what I actually have here is I have this. This is something I downloaded from Thingiverse. So this is actually this. Alex, if you come back to the outside world. This was a case that I downloaded a long time ago because it allowed me to put my Raspberry Pi in here along with a screen. And I was able to make a little portable module with a touchscreen at the top.
Yeah, pretty nifty.
It's pretty nifty, but it didn't suit my purposes because I wanted to put a bunch of other stuff in here. The only thing that really fits in this is a Raspberry Pi, maybe the screen on top, and everything else has to be external.
Right.
Again, I wanted something that I could prototype off of, which means I needed a little bit of extra legroom. But if you go to the Tinkercad, I didn't feel like redesigning the entire thing. So rather than measuring the spots to all of the various mounting holes on the Raspberry Pi, I just said, hey, you know what? We're going to take this 3D drawing and we're going to embed it into the box.
And then you're just going to build around that.
I'm going to build around that. If I wanted to, and this is one of the things I like about tinkering around with these items. Take something you like and then modify it. Now this was not all that modified. It's basically a box inside of a box, but this allowed me to play around with the dimensions. I started measuring out batteries. I started measuring out the different components, clearance heights. And the nice thing about doing it this way is because it is a fast prototype and because I was able to print this half-height box. This is actually a full-height box, but I printed a half-height. I was able to print this in about 5 hours, and then take a look at it and say, oh, I want to change this. I need more clearance here.
That is the beauty of quick prototyping.
That is the beauty of quick prototyping. There is something that's different about this prototype versus the prototype we did for the Twit badge. Alex, if you go back, when we did the Twit badge, what we did was we made a solid box, and then we put negative space inside the box. You remember that?
Yeah.
Yeah, so it was basically an empty box inside of a solid box to make a cup.
Right.
These are actual walls that we've created.
Oh.
And we did that because we needed to make more complex structures inside of our box for the prototyping. This also gives us the advantage of being able to modify down to the minutia where we want the support members of this box to be. This thing is actually incredibly strong. It's 3 millimeters on all sides, including the floor. And I was standing on this, so it is pretty strong. I'm not saying you need it that strong, but again, because this is a multi-purpose prototype box, we wanted something that could handle some abuse. Because in the future, I want to do things like make this a sensing platform. You know, put it outside, make it waterproof. But yeah, so that's the Tinkercad version. I really suggest, if you have any inkling whatsoever of getting a 3D printer, start playing around with Tinkercad. The more you play with Tinkercad, the more you look at objects and you say, oh, I know I can make that.
Well, even if you can't get your hands on a 3D printer, I guess you could always send your design to a company that will print it for you and then ship it to you.
Yeah, Shapeways is really good for that. They're a bit more expensive, but and I kind of like the ability to make a prototype part and say, oh, that didn't work, and then remake it and then reprint it in another 5 hours.
There is something to be said for being able to make the case and then wiring it. Like you can do it in your head 100 times, but until you physically put the wires in and like see how everything lays out, you're probably going to want to change a few things.
Right, exactly. But so what we're going to do is we're going to have the full instructions for the
RetroPie MAME.
RetroPie MAME, and we're also going to be putting the link for this particular file. I want you to tear it apart. I actually can go ahead and modify the STL file so that you can take this and show me what you want, because I want to see what designs you come up with. That's one of the fun parts of doing know-how. We get to meet some brilliant makers. Some people who say, hey, you know what, I'd like to do this prototype box, but it's for a specific use, and this is a specific use, and this is why I modified it.
Yeah, I'm wondering, I would like to do a puck. I want to do like a circular case. That would make it difficult for making connections flush and everything.
But actually that's kind of cool.
Or
a Ras puck.
A Ras puck, yeah, and it's like it's in this little container, a puck, and then you take it to someone's house, and all you have to do is plug in controllers and an HDMI cord to put it in TV and play old games.
I think that's the difference between you and me. I have no eye for design. I'm like, but a square is far more efficient.
Yes, I'm great with coming up with those ideas, but actually making them work, yeah, I think I'd transfer that over to you.
No, that's not how this is worked. This is a shared show, Brian. And speaking of shared shows, we can't stop talking about our little Raspberry Pi project without talking about making it portable, specifically about powering it portably. Now, you can do this. In fact, we have done this. You get one of these super cheap USB batteries, and this absolutely will work. All you have to do is connect the micro USB plug into your Raspberry Pi, power up your battery, and now it will power for as long as the battery will last.
And the Raspberry Pi needs 5 volts, 2 amps, right?
5 volts. Well, okay, so it actually pulls about 5 volts between 187 and 250 milliamps.
Okay.
So it's really going to pull between 2 and 5 watts.
Okay.
It's not that much. That's why this little teeny tiny battery can power this thing for about 6 hours. Now you'll notice here I have this little meter that actually gives me the state of the different cells inside this lithium poly pack. This is not the most efficient way to power my Pi, by the way. The only reason why I'm doing this is because I have a lot of these for my quadcopters. But I would probably go with a different battery technology, one that is okay with deep cycling, because with a lithium poly pack, you should only really go down halfway and then stop. If you go down below that, that's why I say 6 hours instead of 12 hours, because you don't.
What happens if you go all the way down?
Puff it. Yeah, that's bad.
Yeah, I think we've had a few the little quadcopter batteries have come to that heinous end.
Yes, they have. Now with this, there are some people in the chat room who are pointing out that there are really easy ways to buy a device that will power the Pi. This is actually easier, and it's cheaper, and it gives you a better quality. So we're going to go ahead and play you a little video of how you use 2 components to make yourself some mobile Ras power. To power our Raspberry Pi through the GPIO power pins, we're going to need a few parts and tools. I'm using a variable voltage regulator and an LC line filter from Ready to Fly quads. Purchased for less than $4 total, these pieces will allow me to supply 5 volts of clean power to the Raspberry Pi. This is very important since we're going to be bypassing the fuse, regulator, and line conditioner built into the USB port of the Pi. I also purchased a pack of breadboard jumpers for about 99 cents, a female JST connector, and heat shrink tubing that can fit the regulator and line filter. Tool-wise, you'll need a multimeter, wire snips and strips, a soldering kit, a small Phillips screwdriver, and if you've got it, a hot glue gun. Start by snipping about an inch of wire from the JST connector. You'll be using this length to link the regulator to the filter. Strip and tin your wires, then solder the JST connector to the in pads of the regulator, making sure to line up the red wire with positive and the black wire with negative. Now, using the wires that you cut from the JST connector, connect the out pads from the regulator to the in pads of the line filter, once again making sure that red goes to positive and black to negative. Now we need to test our solder joints and set the regulator to 5 volts, the voltage that we need for our Raspberry Pi. Connect a power supply to your JST connector and attach your multimeter to the out pads of the filter. I'm using a variable power supply, but you can use any power source that can output between 5 and 19 volts. The multimeter should now register voltage. We haven't yet set the potentiometer on the regulator, so the multimeter should show you a voltage that is close to the input voltage. Using a small Phillips screwdriver, turn the potentiometer on the regulator until the multimeter reads 5 volts. Once set, that regulator should keep the output voltage within 0.05 volts of the desired output, as long as the input voltage is between 5 and 19 volts. With your voltage set, disconnect power and drop a small dollop of hot glue on the potentiometer to ensure that vibrations don't change the voltage output. Remember that we're bypassing all the built-in power regulation and conditioning on the Pi, so we need to regulate the power as much as possible with our harness. Pulling a black and red wire from our breadboard jumper pack, cut off the pin ends of each wire, then strip and tin. Solder them to the voltage out pads on the line filter, black to negative, red to positive. With your wires soldered, it's time to shrink wrap the regulator and line filter to protect them from shorting. The shrink doesn't need to be tight, just snug enough not to pull free during use. We're now ready to connect our completed power harness to the Raspberry Pi. Be sure to connect to the 5-volt pins and check your polarity. Any mistake here will kill your Raspberry Pi. On the Raspberry Pi 2B, look at the board with the USB and Ethernet ports pointing downwards. The power pins are the first 3 on the top right of the GPIO header. The first and second pins are 5-volt positive, while the third pin down is ground. Connect your power harness to the pins, black to the third pin down, red to the first or second pin down. Once again, double check before applying power. All of your wires, all of the pins, all the black and the red, because nobody likes a burned Pi. Once you're satisfied that it's right, connect power and you should see the Raspberry Pi light up. If so, congratulations, you now have a harness that can safely power your Pi through the GPIO header.
Burnt Pi. You couldn't resist.
I just couldn't. I had to put in some pun, something punny. I will say, because we're running this off of a battery, we probably could get away with just using a regulator, because that's going to provide pretty constant voltage. This is going to be able to provide pretty constant voltage, clean voltage off of a battery. The reason why I wanted to put a line filter in there is because I wanted hybrid power options. If I use a 5-volt AC to DC adapter, there will be all sorts of noise that gets injected into the line. The LC line filter uses an inductor and a capacitor to sort of even that out. It's actually a really inexpensive way. This is $3. It's an inexpensive way to make sure that you get clean power into the Pi. And again, because we're going through the GPIO header instead of the USB port, it means that we're bypassing all of the power protection that's built into this.
Right.
This actually has a small capacitor and a small inductor, so that if I get dirty power in, it's not going to kill the Pi. If I put dirty Pi into the GPIO, I will blow this up.
You said dirty Pi into the GPIO.
Dirty Pi.
Yeah, I've pretty much memorized what all these pins are from doing these projects.
Right, right. Well, I mean, you have to. And actually, Alex, if you go and show them the first picture, the GPIO header picture, This shows you the GPIO layout for the Raspberry Pi 2. And actually go to that second picture, and it will give you there we go.
Yeah.
So those first 3 pins on the right-hand side, up to down on the GPIO header, that's your 5-volt power rails. You get 2 5-volt, and then you get ground. So that's where you have to connect. When you're doing this project, please, I'm not just paying this lip service. Look. Make sure everything is lined up. Test with your multimeter to make sure you're outputting positive to the wire you think you're putting positive to.
Yeah.
Because if you reverse this, it's not a question of it will kill the Pi. You will blow it out and you have to buy yourself another one. So don't do
poor
that.
little Pi doesn't deserve that.
It doesn't. You guys should the Pi. But because we've done it this way, this allows us to have a system that we can put other power options through, and we've now designed our initial harness to be able to take multiple voltages. Again, this can take anywhere between 5 and 19 volts to supply this Pi, and it can take battery power, it can take AC to DC power, it can take dirty battery power. So yeah, let's do that.
Planning ahead. I like it.
Planning ahead. Now, one last bit of nerdvana for our Raspberry Pi Wonderland.
Yeah,
it's got to be this.
Is that the title of today's episode?
Yeah,
Raspberry Pi Wonderland.
Boom.
What you got there?
The official 7-inch touchscreen for the Raspberry Pi. There have been other touchscreens that you can get. In fact, I've got a smaller one right here. These were kind of a pain in the butt because they're not official. I mean, they will work. You just have to set them up properly. This one actually does come from Raspberry Pi. Right now, if you want to buy one of these, Alex, can you bring up the Amazon link? They're going for a premium. This should be a $60 screen.
Whoa.
Yeah, this is going for $92 right now. I would wait because it's going to come down to $60, and that $60 is supposed to be the price. It's just that they're in such short supply right now. It's hard to get one of these.
How did you get one?
Well, because I paid the premium.
Yeah. Okay.
I paid 50% more than I had to.
So that's where all the know-how money went.
I know. No more steam buns.
We did it for you, the audience.
It's because we love you. That's right.
Yeah. That's right.
All right. So let's go and take a look inside the box. This is the official for a couple of reasons. Let me show you some of my favorite. Okay, so when you open it up, you're going to get a couple of pieces. This is the adapter board. So this is what drives the LCD, and this is what allows it to hook up to your Pi. So of course you've got power, little micro USB port, just like you have on the Raspberry Pi. This will take both of the ribbon connectors from the screen, and it will give it out to another ribbon connector that you can then connect to your Raspberry Pi.
Maybe Pi.
I know, it's a little mini Pi. It does have all the pieces, but this is the beautiful piece. I mean, this does look like a lot like the screen from a Nexus 7. It's nice and thin.
Maybe it is.
It is. But here's the cool thing. This is what I really like about this. There are actual mounting points.
Nice.
So I don't have to bodge something together, although I will be doing a 3D print case for this. This gives me mounting points both for the case, so this is where I can screw in the back end of this, and it also gives me a place where, let's see, the Raspberry Pi fits perfectly. There's actual mounting posts for this.
Okay, I'm liking this more and more.
Yeah, exactly. So the way it's going to work is that will connect to the board. There are 4 standoffs, and that will connect right up here. So, I mean, yeah, you could make yourself a tablet. It would be a pretty thick tablet.
Yeah.
But what I'm thinking is if I build a 3D case around this, based off of our prototype box, I can have a really nice prototype box that has a built-in screen. I don't have to connect this to anything. Now, imagine what that means. It means that I no longer have to have the HDMI coming out of here. This thing can be completely wireless, completely independently powered, and I can even put in like my wireless keyboard and my wireless mouse, maybe even my my wireless game controllers, so that this becomes an all-in-one mobile prototyping device. What do you think, Brian? Worth it?
Really like that, and I'm trying to visualize how big the old Game Gear was and the old Game Boy. Like it wasn't. I mean, they're almost about that size. So
I'm gonna name it BMO.
Oh, little BMO robot.
It doesn't look like BMO though. It's too.
Well, you could have a little face pop up at the beginning.
If I wanted it to be BMO, the case would have to be like this big.
Yeah, that would be really big.
Actually, I need a bigger 3D printer.
Yeah, because how much is your bed that you have on the
5.9 inches by 5.9 inches. Although I am getting a new printer.
Well, yeah, because all the other ones are broken.
They're all broken. It will do 8 inches by 6 inches by 8 inches. So that might actually kind of work.
That would be cool. Do a little BMO.
No BMO. How about that? Well, Brian, unfortunately, we've gone way over time for this episode of Know-How. Again, folks, this is what Know-How is going to start to look like. We want to do more and more of our themed episodes rather than sort of just bodging together a bunch of different topics.
Who knows what the next Wonderland episode will be?
Yeah, maybe not a quadcopter Wonderland. I know there's a lot of people who are sick of that.
Probably will be. We should probably do a holiday. I was almost going to say Christmas, but we're not going to exclude anyone. Holiday episode.
There will be a holiday episode.
I want to do like programming lights or something.
Yeah.
You know, to music.
Actually, that's, thank you. Thank you for reminding me. You suggested that project, so I dug into my project box and I found this.
What's it? That
Well,
looks
I
like
don't
a
know.
SCADA
It's
control
no,
thing.
it's a little relay board that allows me to control AC power through the GPIO headers on the Raspberry Pi.
Oh.
So if, say, I wanted to hook up a bunch of Christmas lights, I could turn them on and off with a simple Python command.
That's exactly what I want to do.
That's what we're doing. How about that?
Sweet.
Sweet. Now, folks, we know this was a lot of material. If you want instructions for the RetroPie, if you want to get the instructions for putting together the little power thing, if you want the STL file from our 3D prototype case, you need to go to our show notes, which are where, Brian?
twit.tv/KH, and that's where all our past episodes are as well, and handy links for downloading and subscribing. Yeah. Check it out.
And don't forget, we have a Google Plus group. It's actually a very, very active Google Plus group. It's over
Google Plus got
9,300
updated.
members. Yeah. So go and update your subscription to Know-How. It's a great place to put questions about projects. You get a lot of answers from the know-it-alls. It's a great place to put pictures of your finished projects, videos especially, because we like to include that in the show. And of course, any questions you might have about a future project.
I know there's going to be some mamers out there, some guys who outdo our MAME machine.
Yeah,
but you know what? I look forward to seeing it. I challenge
Outdo
you.
us. Do it. I love it when people have something I go, oh yeah, I'm going to copy that. That looks really good.
And then we'll have
what
it on
we
the
do.
show.
Yeah, we will. Also, if you don't like Google Plus, you can find us on the Twitters.
That's right. If you want a behind-the-scenes look at our everyday thoughts, and which would actually be really scary. So if you want to be scared, follow us on Twitter. I am at @cranky_hippo.
It's mostly cats and dogs.
Corgi.
I follow the Rubber Ballecer. I'm a Padre SJ. That's at Padre SJ. And we have a third member of our crew, don't we?
We do?
We do.
We do?
We do?
It's Hal Gimpy or.
That's the voice I hear in my head telling me to wrap it up all the time.
That's
oh,
different.
it's a different voice.
Okay. It's Alex Gumpel. You can find him on Twitter at ANELF3.
And what were you saying about a holiday show?
Yeah, probably.
Holiday show.
Why is the snow going?
That's a good question.
No.
There we go.
Yay.
We have an anti-gravity holiday show coming for you folks.
It's not even December yet, and it's snowing.
That's what we love. Until that holiday show, I'm Father Robert Ballecer.
And I'm Bryan Burnett.
And now that you know how,
Go put a sweatshirt on.
he's cool.
It's snowing in here. It looks so real. Make it come from the floor. We're in a snowstorm.
Now it looks like a star field, a warp or something.
Ooh, yeah, I like that idea.